We're privileged to have a pre-conference workshop submitted by speakers from CDC, the National Center for Health Statistics, talking about a very timely and maybe even pop culture issue with ChatGPT and large language models. And so before they begin, I just want to review today's agenda. So if you're attending this session, there's a separate session for the afternoon, separate Zoom link and registration. If you haven't registered for that already, please do so and join us this afternoon. We have a really great agenda for today, though. In addition to this morning's workshop, from noon to 5, we have some packed sessions of contributed papers, lightning talks, and we'll conclude the day with our plenary keynote talk by Dr. Douglas Bates of University of Wisconsin, giving an insider's view of open source software for data science. So with that, let me turn the slides over to the presenters and they can introduce themselves and today's workshop topic. Thank you very much for joining us.
Thank you for the introduction, and let me share my slides and let's get started. All right, double checking that everybody can see the slides.
Yes, we can.
Great. Welcome everybody to ChatGPT, a first look at the utility and risks of large language models for federal agencies. This is a really cool seminar, and I think it's really, as Nathan said, it's really timely. I've been giving a version, so has Ben as well, a version of this talk many times because everybody wants to know what's up and how to use this and should we be using this. So I will touch on some of those things, but I will strongly point out that little disclaimer in the bottom that these are the conclusions of Ben and myself. They do not necessarily represent either NCHS or CDC, although I can tell you federal agencies are actively working on what to do with ChatGPT and large language models in general. I am Travis Hoppe. I'm the Associate Director of Data Science and Analytics here at NCHS, and I'm joined by my co-author, Ben Rogers, who's a data scientist here as well. So really quickly, a session outline. We're going to have some introductions to myself and Ben. We're going to talk about generative AI, the technology behind it. We're going to give some, we put together some nice examples about how ChatGPT intersects with public health, because we are kind of, at CDC. And then I know not everybody cares about public health as deeply as we do. So we kind of have a fun frame story that touches on some of the ways you could use it in a creative way around Tom Brady. And then, we have about 40 to 50 slides. And I feel like we're going to use up a chunk of the time, but I do think every time we've given this talk, there's been some fantastic questions that have come up. And as Ben and I are going to trade off on the different session, we can answer some of these questions in the chat as much as we know them. But I feel like it would be a really good time to have some discussion and conversation afterwards, because each group brings a unique perspective to this conversation. And there's a lot of myths to dispel, and we'll try to get to some of those, but there's also a lot of excitement, and we want to touch on those pieces as they come through. So a little bit about myself. I recently led a Tiger team at CDC that sounds a lot like the title of this talk, really to look at what does it mean to have conversational AI and bring that to CDC, bring that to public health. And we came up with a lot of really interesting findings, and we're working on sharing that with other federal agencies. I have published a little bit in this field. I have a paper in Science talking about topic choice that uses NLP. The competitor, so OpenAI is the company that publishes ChatGPT. Early on, before I joined CDC, I published a paper that was kind of we need an open source version of that, and that is the Pile. I put that one out there. And I do want to call out, and Ben worked on this as well. We published a model, and it's up on Hugging Face, and I think he'll touch on that a little bit. I have a background in physics, which ended up being really useful for AI and ML because a lot of the math is the same, but really have joined CDC and really love the public health community. So I will turn it over to Ben to introduce himself.
Amazing. Thanks, Travis. My name is Ben Rogers. I am a data scientist, like Travis mentioned, with NCHS. I was a member of the Tiger team that Travis mentioned. Travis was the lead. I was just one of the writers, but it was a very fantastic time to listen to everyone talk about generative AI and from their perspectives of different roles and positions, which is one of the things we also look forward to every time we give this talk, is to hear other people's perspectives. So please, if you ever have comments or questions, please put them in the chat during this presentation. Travis and I will be actively replying during the presentation, so please put those in the chat. Just want to plug that again. And I also, like Travis mentioned, just give a little shout out to SANS, our AI model. This is, I believe, the first one published by CDC that's available, I think, but don't quote me on that. Where if you have open-ended survey responses and you want to filter out all those gibberish, all those I don't knows, all those just refusals to answer, and get your data set to a qualitative ready study, or to be able to qualitatively study, that's what SANS is for. It's a model to help remove all those different ones, and it's meant to be working with human reviewers during that process. But yeah, that is an intro for me. Pass back to you, Travis.
Thanks, Ben. So I will note that AI is not just ChatGPT. Like, we're talking about ChatGPT and a little bit about conversational AI, because I think some of these things hold, but there's a whole field of AI. And right now we're really focused on ChatGPT, we as a collective community. But I think we just need to keep in mind that there's lots of other really interesting things happening, and not lose sight of that. So who are we? We are NCHS, and I'm fairly certain a lot of you know NCHS. We're one of the key 13 statistical agencies, which I think is many of the audience here, so I don't need to inform you guys what a statistical agency is, but we kind of focus on putting out population surveys, vital statistics, provider surveys, which are really interesting and really useful to kind of get a sense of what America is doing across health-related statistics. Since we started a while ago, that we brought a lot of projects into it. We have the SANS model detection. We have a project to detect PII across free text. We do a lot of work in named entity recognition. For us, recognizing drugs in death certificates and EHRs is a big deal. And so I just kind of wanted to list a lot of these things here on the bottom, just to show you that, like, AI is not just ChatGPT, and I know a lot of you are interested or working in this. And I think, as much as possible, join the other AI community of practices if you're interested in this. For my colleagues at HHS, there's a good one there, HHS community of practice, but there's also a GSA one, and I know they're doing a lot of work on that. And for those of you who are a little bit higher up, I know there's all these sub-IPCs that are working on drafting the national AI strategy. All this work is happening, and I think it's really coming from the contribution of all of us here on the call. So let's get into it, the thing that you came to join here. So what is ChatGPT? We're going to go through some of these terms a little bit more in detail, but it is an autoregressive large language model using reinforcement learning, and that's how it's trained. And if you look through this, there's a lot of text going on here. There's a lot of kind of terminology that you might not be familiar with, but you can just ask ChatGPT what it is. And this is my favorite slide because it really kind of hints at, like, the power and utility of ChatGPT. I mentioned words like large language models and reinforcement learning. And while it doesn't actually mention those when you ask it to explain itself like it was a 5-year-old, this second paragraph here that it responded with, now this robot friend learns by copying how people talk, which is really what large language models do. They look at large pieces of text in a statistical way, and it gets better and better by listening to people's conversations. That's all reinforcement learning is. We have a few more slides on it, but really that is the heart of it. And it's really fantastic sometimes by taking something that's dense scientific jargon and kind of making it a little bit more human readable. Lots more utility, but this is the one I want to open with. So ChatGPT is published by a company called OpenAI. It is a state-of-the-art conversational chatbot, and it is trained to provide human-like responses to many, many different tasks. Within a few months, it had 100 million users, which is a lot of people, and it likely has many, many more than that. It's really important to note that it has a free and easy to use interface. And I don't know if you're running a federal agency or you're concerned with people using it, that really does increase adoption for better or for worse. It also has an API access for all my data scientist nerds out there that want us to, programmatically kind of go through and use ChatGPT. So it's happening, and it's happening really quickly. Models and not just ChatGPT, even though I'm using this as an example, they're being developed extremely rapidly. I would say the pace of innovation, instead of being on years for many different fields or on decades for other fields, it's every 3 to 6 months. And a really good example of this is ChatGPT was released, and its core large language model, confusingly, they call it GPT 3.5. They released kind of an update to it, GPT-4, which they had a little bit more training data. But when they released it in November last year to the public, it was getting the 10th percentile on the bar exam and 40th percentile on the LSAT. That's really good. I can't do that. But it really just took the text responses from those questions and responded in natural language, and that's how it was graded. But within like 4 months, they released this newer model, and now it's getting 90th percentile on the bar exam and 88th percentile on the LSAT. And so I think people on the internet have argued, it's like, ooh, maybe you're not actually 90th percentile, or you made the 70th percentile. I've seen papers on that. It doesn't matter. None of that matters. What you need to know is we're on the exponential growth curve, and we probably will be for a while. So any of your ChatGPT can't do this, I want to add ChatGPT can't do this yet, or conversational AI can't do this yet. So as you're thinking about these models, think about what problems may be solvable soon that we're not. Tricky thing about AI innovation is that it's really hard to predict what new innovations are going to happen, but you just need to be expecting innovations will be coming out. Here's what we're not going to talk about, which is the Pope in a Balenciaga jacket and all these really cool things going on. This is not a real picture. This picture was shared widely across the internet. It is made with an image generating software called Midjourney, and there's a few others. There's DALL-E 2, which is made by the same company that makes ChatGPT. There's Stable Diffusion. All of these things do some really, really cool technology to either copy styles or create images just from a text input. So it's kind of like how ChatGPT will respond with text. These programs will respond with images, and there's a lot of interest in this. So like if you're an artist and digital artist or anybody in the creative fields, it is taking the world by storm, and people are really excited and really scared and really angry about that. But we're not talking about any of this. So this is the scoping slide. I want to call this out because I think it's really important, and it's evolving right now. So if you use that free web portal to OpenAI, and you type in your stuff, and you're like, cool, let me ask all these questions, let me put my resume in it, let me put some data from my work in it. Don't do that. They have in their terms of use, if you put anything into that public portal, they effectively own that information to be used for future training data forever. So once that information leaves you, it's gone. This is also true in the paid version of the portal as well, which is a little confusing. If you pay for the portal, they still have the right to train off this data. If you use what's called the API, which is how like computers kind of talk to each other, they say that they're not using it for training data. I am not a lawyer, and nor am I giving you advice on behalf of our agency or yours, but I would make sure that you kind of check with your agency's guidance and not use it for any official output purposes. But like I said, this is evolving very quickly. I know ChatGPT is working with, OpenAI, the company, is working with Microsoft, and there are endpoints set up. Whether these things are considered FedRAMP, if you're within the Azure ecosystem, I think we're trying to figure that piece out now, but I know it's actively happening. And from what I can talk to across the US government, it's actively happening in every single agency right now. So somebody in your agency is probably really worried about it and probably thinking about the answers to these questions, but don't use the public portal for anything that is uncleared data. I do want to point out all the things that are happening. If you're like, Travis, this is really exciting, but oh my gosh, what about trustworthy AI? What about all these crazy things that are happening? Has anybody thought about it? Yes. The White House has thought about this quite a lot, and they've convened so many different things that are related to this. I want to just touch on some of them. And I think we can share these slides afterwards. So I know these are links, and if you're interested in one of these links, I can drop it in the chat when I turn this over to Ben. But I want to start off with the bullets on the bottom here. OSTP for a while put out the blueprint for AI Bill of Rights, and it's kind of a framework in which a lot of these things are being developed. There are two kind of big EOs, executive orders from the president, both this president and the prior one, about trustworthy AI and maintaining leadership in AI. And really importantly, OMB said they're going to provide guidance on AI and specifically generative AI in the fall, which is so fast for OMB. But if you work in a federal agency, it will probably, federal agency, it will apply to you as well. If you're looking to develop AI within your organization, doesn't matter what level, I so strongly recommend you start looking over the NIST AI risk management framework. It is so good, but it's also really dense. It's a lot to read. They also released a playbook, which is like a website that you can click through, and it's got fun examples, and it's a lot easier to digest. Start with the playbook, and if you like need policy pieces that you can reference, like NIST said this in this section, blah, 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 go for that. It's so, so good. I want to call out a few other, department level things. HHS has this trustworthy AI playbook. It's a little outdated now because they came out a few years ago, but also the Department of Ed just put out something which I think a lot of questions are centered around education. Like, what does ChatGPT mean for the classrooms? And they do touch on that there. And this is the department's level response to something like that. So very, very interesting. So many good things. Every agency, every department, and all the way up at the executive office of the president, they're thinking about this and thinking about ways to promote trust and safety in AI as much as possible without stopping innovation. So a little bit about, I'm going to switch gears and talk about the background of ChatGPT. This is kind of the training portion of it. ChatGPT is a series of models, and it's kind of built up. So a paper came out that talked about this kind of core technology. So there's a lot of neural networks that exist, of which ChatGPT is one of them. And there's these convolutional neural networks, recurrent neural networks, deep belief networks, so many different networks. A while ago, this paper came out that used a technology, a architecture called transformers, and that really did change the game for almost all of AI. Transformers have some key features, which we'll touch on really quickly, but one of them is attention. And the model that kind of really started all this was this model called BERT. And BERT is what we call a large language model, and we can consider it a foundational large language model. So it's foundational because it is trained off a lot of generic forms of text or images or whatever that foundational model is, such that it can be used for downstream tasks that are more specific, or used as a starting point for a more complex model. So BERT was trained on all of Wikipedia, which seems like a lot until you realize how big some of these other models are. And then about 10,000 different books. There's a whole family of these models, and I had a picture that I was going to drop in at the end of this like family tree of models, and it's insane. The pace and innovation, we can't touch on all of them, but I want to call out some of these other ones like Llama and Palm, and we mentioned GPT that had come out, and these are all really big things. When we say 7B, 13B, 33B, those are billion. And so like, if you're in the statistical world and you think of words like parsimony, like I want to have as few models, as few free parameters that I need to describe the system, neural networks kind of flip that on their head. They're like, I need as many parameters as I possibly can to encode all of this information, because information is not stored in a neural network. It is compressed down to like a latent state, a representation of that data, which is why it does kind of hallucinate as data comes through. These are really, really big models. So when we say 65B, there's 65 billion free parameters in this model. And we don't have time to get into it today, but there are reasons why that makes more sense than having a smaller, more parsimonious model. There are also open source activities. So it's not just these like big players like Google and Meta and everybody else that are putting out these models, or OpenAI. There's a whole suite of free models, the GPT-J, GPT-Neo, and very recently the conversational AI piece, GPT for all. These are all links. If you were to Google them, you could download them yourself. So you have your own 20 billion parameter model, or a GPT for all, an open source one. There's actually new ones that are coming out all the time. There's Falcon, there's NPT that came out, I think, a few days ago, like a week ago. So many cool models, and a lot of these are open source. So you can't run a cloud-based thing on your private data. Maybe you can run something on-prem. And so these are lots of really interesting things to think about as you think about how this works within your organization. So really quickly, reinforcement learning is kind of wild. You may have heard that, AI solved chess and AI solved Go a while ago, and it solved video games. Normally, when you train a neural network, you're like, this is a hot dog. This is not a hot dog. And you have all these trained examples, and you can be like, oh, you got it right. I'm going to reward you. Oh, you got it wrong. I'm going to reward you. But it's like one decision it has to make. When you play a video game, or when you play chess, or when you play Go, it is so many decisions that it had to make along the way. And how do you go back and say, over the course of your thought process, as you played Mario, as you played Go or chess, how did you get through all these different decisions? And did you win? And what was your score? I want to reward you based off of your score versus a different playthrough, you maybe got a lower score. So that was worked out through this process of reinforcement learning. It's like a really cute little math trick that rewards the certain actions and downplays other actions. But we realized as a research community, you can put this to text as well, because the way large language models work, specifically ChatGPT and the whole family of GPT models, is they're auto-regressive. So I said that word before. What that means is you start with a sentence and you have a new word you could generate, like the cat in the what? In the hat, the cat in the box, the cat in the something. And what GPT does is generate the next word. So that's what it means, auto-regressive. And so somebody asks a response, the large language model gives an answer by finishing the next word. That's not necessarily good for chat-like input. And this is where the reinforcement learning comes in. Human looks at the response and be like, oh yeah, that's a good response. Gives it a thumbs up or a thumbs down. This is the reinforcement part. And all of those decisions it had to make for the next word, that's what's training the model. And this was done at great expense and probably not done ethically as we look into this. So that's a whole separate side conversation about how there are underpaid workers in Africa that were helping train this model. Just putting that out there that we should source our AI ethically. Sound like a vegan call here on this, but lots of questions around this. But that is how reinforcement kind of looks like. And so we call it reinforcement learning with human feedback, because it's getting explicit feedback on whether or not it had a good response. So again, we touched on some of this here, how this works, but there's also large language models just need to generate a response. And so these responses can be harmful, they can be toxic, they can be really bad. We have examples of things at the very end where it just kind of generates stuff. They come this way because they're trained off what's on the internet. And the internet, I don't know if you've been on the internet before, but it's full of terrible, hateful things that exist. And it will find those and will reproduce those. And there's been lots of different stories on this. So what OpenAI has done is kind of put up an intermediate response. It filters really bad inputs from the very beginning, but it also filters out outputs that come out there flagged for moderation. So sometimes if you ask ChatGPT to be like, can you show me how to make a bomb? A large language model would happily fill that out. ChatGPT will actually fill that out for you and then moderate it so you never see it. And so this is an ongoing cat and mouse game. There is a whole community dedicated to getting ChatGPT to say things that they're trying not to, and it will never win. So anything with moderation, and anybody who's worked on moderation communities on the internet, no, it's not about winning. You can't win in the moderation game, but you can help reduce the toxic responses coming out, which is important to know if you start using these models. And we're going to, because this is like a training talk, I want to talk a little bit about this thing called prompt engineering. So the way ChatGPT works is you ask it a question. You say, hey, I'd like you to do this thing. And because it's trained with this reinforcement learning, it gives you an output. But just like when you talk to humans, you can ask better questions. And there's this like burgeoning field in, some people say it's not research. I feel like you're getting better answers from the model. They call it prompt engineering. Is it science? I don't know. Is it robot psychology? Probably in some way. It is a way of elucidating a response from the model that you want. And so in many ways, people have called this programming 3.0, where programming 1.0 is specific instructions you need to run. Programming 2.0 is writing modules that are then called upon by other different things. This is object-oriented programming and functional programming, all these kind of cool things. Programming 3.0 is letting the machine answer for you, and all you provide are human-like inputs to it. But even with any of these like iterations of what we're calling programming, there is a skill involved to it. And that skill, the word I think people are coming around is prompt engineering. So you want to be more specific, unless you just want broad responses, the more specific you can be, the better. So zero-shot learning is just kind of setting out, this is what my intention is, like design for me a playbook for AI. It will do this. But the more specific you can have, the better. There's this idea of few-shot learning where you provide a few examples. So zero shot is just tell me the answers to this. Few shots like, look, I am going to translate sea otter to this word in French. Peppermint is this word in French. And cheese is, and you leave it blank, and the large language model is like, oh, I see what's going on. It's a game. I know how to play games. I will finish up the next word. Few shot learning, generally, if it exists, works pretty well and works better than what we're calling zero shot learning. But we're kind of interested in zero shot learning because we just want to ask good questions. And that's where a lot of prompt engineering comes through. And so you could do something like this. You could say, like, give me 4 business names. Cool. Stellar Solutions, Nexus Ventures, Harmony Enterprises, Apex Innovations. I like how these are all sci-fi based. Maybe I didn't want that because I run a doggy cleaning business in DC, and I provide cleaning and haircuts and a doggy swimming pool. And that's a fair thing for it to ask, but I didn't provide any of that input in this. And so this is a silly example, I know, but I think it's worth looking at what the responses that came out of this. And this is just literally the first 4 things that came out of it. It said pause and polish, wagging waves, canine capital cuts, bark and splash. And so it did give 4 responses. It actually gave 15. I just cut them off. But these different responses did not all have to incorporate all of the things I asked for. I asked for cleaning and haircuts and swimming pools in Washington, D.C. All these kind of contextual clues, but canine capital cuts only covers one of them. Bark and splash only covers one of them. And so it really did try to incorporate them as much as possible. If I wanted a long name that incorporated all of them, literally all you have to do is ask. But this idea of asking is what we're calling prompt engineering. And it does take a little bit of skill. It is tricky to go through and run, prompt engineering across the board, because the way you speak to a bot like this, a chat bot, is a little bit different than you would speak to a human. Although I would say, I think that bridge is closing. But for now, if you want to be good at it, if you want to be an AI whisperer, work on your prompt engineering. And the best way you can do that, I think, is playing with the free software as it exists. So now I'm gonna turn it over to Ben, and he's gonna go over a lot of really fun examples. And then as Ben finishes, I want you to start thinking of questions, because we did leave some time for discussion. And I think we can turn on voice for all the people on here. And if not, we'll answer through the chat. So I will pause, and Ben, it's all you.
Awesome. Thanks, Travis. Give you a break from talking now for a little bit. So now we're going to go over some examples, because in large part, you may have heard everything that Travis said and say, wow, this is great. I have a better understanding. But sometimes you just need that example to see, okay, now it all clicks here. So a couple of important things. All the outputs that were generated were using GPT 3.5. Whenever you do use ChatGPT, it's always good to say which explicit model you're using, or any of the different large language models or conversational AI, just because they're all are a little bit different from each other. And so just saying that is an important disclaimer. So all these outputs are generated using GPT 3.5. And so on our next slide, let's go over some good examples, especially, we're CDC. So let's talk about some public health. These are some of the things that we've brought up to others to say, hey, this is how powerful ChatGPT is. And one of these is it can summarize text and use plain language. Like earlier on, we talked a little bit about SANS. SANS is one particular task type of model. ChatGPT is a generalist model. It can do so many different tasks. In summarization is one particular task for large language models that it can do. ChatGPT can do it. It can use plain language. It can make all these things just a little bit simpler here. So, for example, we've had so many different things about staying up to date with vaccines. There's so much technical knowledge there. If you wanted just to be, hey, here's something a first grader can understand, ChatGPT can do that, because it's been trained on a bunch of information that is specifically meant to go to first graders. On our next slide, you can see that also it's not just trained on English, it's trained across so many different languages, and you can have it respond to you in those other languages, which is so fascinating. It's so amazing to see just how much knowledge this has. So maybe if English isn't your first language or you're in a different language, different format, ChatGPT can be a very useful tool, or other different types of generational AI can be a very useful tool for you to help understand. On our next slide, this is one part that really hasn't been talked about as much, but Travis and I really do see the values of this, and that's providing critiques and probes for implicit bias and just where you might have some flaws in your logic. So here on the screen, this is some different things that were recommendations for COVID-19 about if you've been exposed. Here's some different lists of instructions. So as somebody who was on the COVID-19 response, I can say it was very hectic, very fast. And sometimes you just don't necessarily, there's some things that can just slip through implicitly. You have that implicit bias. And so you could just ask ChatGPT, oh, what are some of these biases here? And if you look at wear a high quality mask, or okay, make sure you can to improve ventilation at home, maybe make sure your airflow is good, make sure to separate yourself within your home from others as much as possible. Well, what if somebody lives in a small home? What if somebody doesn't necessarily have the access to high quality masks or other different information? And what if somebody doesn't have access to emergency medical care immediately? There's all these little things that can be you might not necessarily think of right away. And especially when it comes to your own logic, that is a great point of view. One of my favorite uses of ChatGPT is to say, okay, this is a statement I would like to say. What am I missing here? What is my what am I missing logically from this statement? And that's something that ChatGPT is just great at providing critiques on. And on our next slide, since ChatGPT is generated on so much text, it is very good at drafting formulaic responses. So Health Alert Network, for those of you who are unaware, the CDC has a Health Alert Network to provide emergency updates for different public health events that are going on. So here we asked ChatGPT to generate a health alert network message for the silly virus. Full disclaimer, silly virus is a fake virus. The name is silly in it within a reason. It is not a real virus. This is just a silly little example. And since all the health alert network messages are publicly available, there's an archive of them, and the type of information that would be displayed that the different public health networks would need for it are pretty common across all of them. Okay, you need to know how many cases there are, how many states is it spread to, what are some different recommendations for how to handle it. All of those are common across these different HANs, and ChatGPT has been trained on them. So any piece of information any piece of text that's been publicly available and is on the internet prior to 2021, you should assume that ChatGPT has been trained on it. And that means anything we have created as federal agencies. So on our next slide, I do know that we are going through these examples very fast. We do want to get to that discussion. So please, if you've seen any, put them in the chat, ask questions. You can ask questions to Travis and I, we will respond as we've done before. But it's not just HANs, it's other also types of formulaic responses or formulaic outputs, such as MMWRs, such as abstracts, such as these high quality papers that are out there, because MMWRs are available to the public, because archive exists and there's just so many published papers that are out there. ChatGPT has been trained on them, and so it can say, okay, this is what's happened across so many of these different reports. This is what would be included. And so, okay, and ChatGPT has no idea what the silly virus is. The silly virus is a fake virus. I know, saying I here as ChatGPT knows, okay, this is what an MMWR on a type of virus would include. This is the different information. Here's where different links would be. Here's the different values, and put that all into a draft MMWR here, which is just so incredibly powerful. And going on to our next slide, let's talk about some downsides of ChatGPT, because it's all very positive. I use ChatGPT almost daily. There's probably a lot of people in here who do. It's really important to focus on the downsides, because at this point in time, if you've used it, you probably know the potential of ChatGPT. And so on our next slide, there's one thing in that last message that we put in, which was we put in some fake information. And so that MMWR, that prompt we gave it, included 60 US states. Obviously, there is not 60 US states, there's only 50, but ChatGPT and how it's trained, like Travis has mentioned, its goal is to provide you as the user what you are asking for. The the feedback model in terms of harmful or that prompt output, it's not checking to necessarily say, okay, this is truly factual. That's a completely different response. So if you are asking ChatGPT to generate something fake, it's not necessarily concerned about, oh, here's a fake thing in response. It's just going to happily put that output because it wants to make what you want it to make, if that makes sense here. And so it includes in here 11 cases in the fictitious 60 states as a part of this. Going on to our next slide, ChatGPT can easily create fake references. This is something that looks so good because, as I mentioned earlier, it's read all the different papers that are publicly available. It knows what a reference should look like in terms of what is reasonable. And so it can generate all these different fake references here. For those of you who may be unaware, xylazine is a tranquilizer. This is why we bring this up. It is currently a very, when mixed, especially with fentanyl, it can be very dangerous and can lead to fatalities. Xylazine is not approved for use in humans. And so this is a very dangerous and something that is of concern right now with the opioid crisis. And so it also, an important thing to note, going on to our next slide, is that this came out, ChatGPT was trained, its knowledge cutoff was in 2021. Xylazine, we did not study it, we did not know the effects, especially mixed with fentanyl, until after 2021. And so when you're asking ChatGPT about that information, it has that knowledge cutoff. It might have a little bit because of the reinforcement learning in 2022, maybe, but all of its knowledge is prior to 2021. And so when you're asking it information, you need to be cognizant of that, especially if you're asking it coding questions. If it's a new library that's come out since then, it's not really going to be helpful to you, but especially in this situation, you can see how harmful it is. And then, of course, at the very end, I also do want to give a little prompt. Since ChatGPT does understand that, OpenAI does understand that people will ask it information, it'll sometimes give back a prompt that says, I'm sorry, I don't know this, or as a large language model. It does try to help you identify that, but really it's on you as a user to know the effectiveness and when to use OpenAI and generational and use ChatGPT. So on our next slide here, let's go ahead and now, great, Ben, I know I've seen you have the CDC background. You and Travis both worked for the CDC. That's really fascinating. That's really cool. I can understand why you care so much about public health and all the impacts that it would have. I don't necessarily care. So let's all go to the same place together. Let's all look at this through the same eyes, through this hypothetical. You are now an employee for the hypothetical National Center for Sports Statistics, but you're not a statistician and you don't watch sports. How you got this job? I don't know. It's a hypothetical. You are here, though. This is now your current position. So you've been asked by your supervisor to present a talk on the kurtosis of Tom Brady's career passing completion. If that doesn't make any sense, that's totally fine. This is a hypothetical here. You don't know. I don't know. We're assuming that we don't know what this means in this situation for the hypothetical. But you do know your boss really likes Milky Way bars and almond joys and will interrupt meetings to talk about them. That's all you know. Here you go. Let's just jump right into this. And so what are you going to do when you're given this task to do this study? Well, you always start with a literature review. So let's go ahead and do a little literature review. These are things that were not generated by ChatGPT. This is just the information you go out and create. And it's very important to note that since ChatGPT and general relational AI can make fake information, you don't want to necessarily trust every piece of information coming out. So our literature review, what are the true facts out there? Oh, Tom Brady's a 7-time Super Bowl champion, 64.3% career pass completion percentage. Okay, great. I know who Tom Brady is a little bit now. And also he was in a Mr. Beast video. Great, amazing. Now let's talk about kurtosis. What is that? That's a term I've never really heard of. Okay, well, I've read that the interpretation is how frequently it falls in the tails of distribution or how much is going to produce outliers, but do I fully know what that means? I don't know. And my boss asked me to do this in SAS. Do I know SAS? I don't know. Well, maybe let's pull up my good friend here, ChatGPT. And on this next slide, why don't I just ask ChatGPT to generate the code to do this? Because maybe I'm a Python programmer and I've never used SAS before. The cost of getting a license was something I wasn't willing to pay. And so I only know open source software. Okay, I have to use SAS for this. okay, let me just ask ChatGPT. Let me do a little bit of prompt engineering. I have some data I'm using in SAS on Tom Brady's career, particularly his pass completion percentage. How can I calculate kurtosis on this? And this is where ChatGPT is just so powerful. It says, okay, sure, here you go. This is how you can calculate kurtosis in SAS. Here's, in case you see that little black box, it puts out the code in a format you can copy. It has a little copy code button. You can click on it, go over to your SAS window, hit paste, and run the code just to see if it works. You might have to change, where the data is coming from or other different sources, but it's really here created to be an assistant for you to help. And it also explains some of the different little bit outputs of what you would expect to see. Now you'd be saying, great, okay, I understand what proc univariate means now, but what is the actual output of this? I don't want to spend the money on a SAS license. What would it necessarily look like? Well, why don't we ask ChatGPT that? And here you can see it generates the output. And one of the most fascinating things is that as an autoregressive model, it generates the next output, that next word. Here, if you look at the different moments, if you look at mean, it's 62.8 here. So when it's generating that number, ChatGPT has an idea of what a reasonable number is for Tom Brady's career passing completion percentage, just like one of us who knew about Tom Brady would have an idea of it. Are the numbers necessarily right? No, but it's within the ballpark of reality, which is kind of crazy to think about. And going on to our next slide, you may be saying to yourself, great, all right, I know the only thing I know about kurtosis now is because I asked my supervisor, what does it mean? What is a potential meaning of it in a more in-depth form? I can't ask my supervisor again, okay? I'm the new person here. This is my new job, my new detail. I need to ask somebody else. So why don't I just ask ChatGPT to explain the output of this code? And here's a 4-paragraph response, which would have taken my supervisor probably 5 to 10 minutes to output. But now they didn't have to necessarily do that. And I have a little bit more of an output of it, to understand what kurtosis is and what this output could potentially show. And going on now to our next slide. Now you may be saying to yourself, great, that's wonderful. Now there's this whole new initiative about moving to R. There's this whole conversation between what programming languages. Maybe personally, I'm trying to learn R. Can ChatGPT just swap languages like that within programming language space and do the same thing? Can it look back at this previous conversation and say, okay, these are the different things I want it to output. Can it reason based off of your outputs they've asked? And the answer is yes, it can say, oh, great, you've been asking so much about kurtosis and Tom Brady, and you have SAS. Oh yeah, I can do that in R. And it's really easy. It's just 2 lines of code. Let me just do that really quick. And here's a couple bits of explanation and other different things for you to think about with it to really try and help you with that. And on our next slide, you may be saying to yourself, great, okay, we've got part 1 down, created the output. I know my boss is just going to jump in about Almond Joys and Milky Way. Can I even just go completely away from Tom Brady? Can I go away from public health? Can I go away from all these other things here and just look at some piece of information so I can be ready for when my boss talks to me about Milky Way and Almond Joy? And the answer is yes. There's probably a bunch of different generic versions of the baking instructions to create Milky Ways and Almond Joys out there on the internet that ChatGPT has probably been generated on. And so you could ask it to mix together the baking instructions for the two to make this cross candy that you could say, hey boss, I want to talk about Tom Brady's kurtosis right now, but I know you're really interested. Here you go. Here's some output. And so you can have some homemade Milky Way and Almond Joy. And this, talking again about ChatGPT in the sense of how generalist of a model is and how much information, there's just a wealth of knowledge here, and it's so fascinating. But now let's go ahead and go forward to our next slide. You may be saying to yourself, great, all right, how can I bring my boss back in? This is a meeting. I talked to him a little bit about Milky Way and Almond Joy, but I really want to get back to my real job here, which is that project on Tom Brady's kurtosis. Well, how about I just tell him this really funny little commercial about how Tom Brady is talking about ChatGPT and Almond Joy and Milky Way cross, and it can create here a little fun script of Tom Brady speaking about Almond Joy and Milky Way. So ChatGPT is so powerful. Hopefully this little frame story can help you see just how wide of a field it is. But let's go ahead and jump now to our next slide. Again, we talked earlier about from a public health perspective, some of the downsides. Let's talk about downsides more of just a general broad part of ChatGPT. And ChatGPT, since it's trained on so much text, it knows that formulaic, that generic recipe to how to create an almond joy. It knows that generic recipe to create a Milky Way. It knows who Tom Brady is in a sense. It knows all these different things. The amount of data that ChatGPT is trained on, you'll see things like, oh, 1 trillion words, trillions of words. It's trained on all of Wikipedia. It's trained on all these different books. One of the issues with scale this large is it reflects all the systemic societal biases that we have. And so when you look down at bubbly and you say, oh, this person is bubbly, you probably in your mind have some idea of what that means. And because of societal biases, society has an idea of what that means. And that's conveyed into ChatGPT. So looking at that image on the right, so you have your statistical and computational biases, you have that human biases, and you have that systemic biases at the bottom. All that systemic biases at this scale are inside ChatGPT. And even if OpenAI has done so much work and all these other companies that are training these large language models and this generative AI, when we're talking about just thousands and millions of pieces of text, it's impossible really to filter out all these different biases. I mean, I'm sure every person in here has written a 10-page report and you realize how much time and effort it takes to edit that. Now, what if it's 1 million 10 pages of reports that you have to remove all the systemic societal biases from? It's inherent in at this point, and that won't be going away until it no longer exists in our society. And going on to our next slide here. Now we're going to talk about some stories about the use of ChatGPT and more importantly, the improper use of ChatGPT. So first and foremost, ChatGPT is not trained to detect AI-generated content. This is very hard in terms of the text space. With images, it's a little bit easier, but for text, it's really hard. And so you've probably heard this story. A professor falsely accused his class of using ChatGPT. The reason he thought they did was he asked ChatGPT, hey, here's my student's output. Let me just put it in. Is this created by ChatGPT? ChatGPT wasn't trained to do that. It's not ChatGPT's job to do that. So it's just said, sure, I created that, of course, because that's what you want me to say as for the professor. And so that's improper use, and it really threatened the lives of these students. Going on to our next slide here, we have now the story about, again, talking about hallucinations and facts and events. There was a lawyer who tried to use ChatGPT to create a court filing. It did not go well. It was a large amount of fake cases and fake information put in, and his career's basically at risk and at jeopardy now just because he thought, oh, conversationally, I can do this for me. I don't have to spend now the hours and hours to actually create this report and do that thing where I can double check all this information on all the court cases names and everything like that. I can just, yeah, it looks good. This ChatGPT output looks good. Let me just submit that. And it had so much fake information that it was very, very damaging to his career. Going on to our next slide. This is one of the most fascinating parts that really isn't talked about, is even in a situation where ChatGPT can generate a great output, it might not be the best case for you to use it. So in this instance, after the fatal shooting at Michigan State, Vanderbilt University used ChatGPT to create the message about it to console the students. Now, there's probably been thousands of these generated, unfortunately, and sadly, that are available publicly that ChatGPT has been created on and has been trained on. So ChatGPT has seen these and knows what to do to write them. But that doesn't mean that the students don't have a very valid reason when they see, oh, this was generated by ChatGPT, that this is you don't really care. That is a very valid feeling on their part to say, okay, my university did not care enough to actually handwrite this response. They didn't want to put in the effort. They just wanted to send that to an AI. That's a thought I would have had as a student. And that is very valid. And there's so many people who can have those different types. There's so many situations where even if ChatGPT or even if conversational AI can do it well, what is the reputational impact of that, of people saying, oh, conversational AI, it was AI generated for this. Maybe that's for your public reports. Is that something that you want people to see? Oh, here's this paper that this agency produced. Oh, it was partially written by AI. Do I really trust that? Or there's so many different questions here that there isn't necessarily a good answer to. It's something you should just be thinking about as you use. Going on to our next slide here. This one is very, very, very sad. So the National Eating Disorders Association, what they do is they have a helpline for those who are suffering from eating disorders to call in or to message in. It is staffed by both employees and volunteers to help those suffering from eating disorders. And so they saw conversational AI. Oh, hey, this is a chatbot. This would be great for us to add in. We could have, all of a sudden, we don't have such a need to have all of our employees and all of our staff people do this. We can lighten part of their workload by having this chatbot. And so they created a chatbot named Tessa to do this. And unfortunately, the chatbot started just after 2 days was shut down. And the reason it was shut down was it gave dieting tips such as maybe you should measure your weight weekly. Maybe you should count your calories. Maybe you should do all these different things in terms of dieting, which can generate eating disorders when properly used and is not the appropriate response by a professional to somebody suffering from an eating disorder here. So go ahead and now we'll jump over to our next slide.
I think, and
Yeah.
importantly, this wasn't ChatGPT, if I'm not mistaken. This was just a different chatbot, but it's a really great example of the improper integration.
Yeah, so now we've gone over a lot here. I know we ended here on kind of a little bit of a negative note with that, just because we've used it and everyone at this point knows probably the potential of ChatGPT. It's really important to talk about those harms. But now, like we said earlier, we always want to leave time for discussion and questions because these are always some of the most fascinating part. So please go ahead and hit us with your questions.
So I'll start off the questions right now because we have a ton in the chat, so I'll moderate this. But if more come in, I'll try to answer them as we go through. Nathan, can you let us know how much time we have left before we have to convene?
Sure. I think we can go to about 11:50 when we shut this. We will shut this Zoom instance down, and we'll have to start a new Zoom instance to begin the afternoon session at noon. So, 25 minutes or so for Q&A, if you can tolerate it.
I think we can, because like Ben said, this is probably the most interesting part. I'm going to kind of skip around because there's so many different questions. Stas, I mean, you're just dropping all sorts of curveballs, as you said in the chat. So I want to hit some of them first, but I'm not going to do them in order because I think there's some really good things that are going on in here. Let me just start with the first one, and I'll read it out loud. ChatGPT is said to have troubles with precise information. 12 plus 345 is fine. Some big number times another big number is not, because that particular math combination is rare on the internet. I want to address that point, but I'll keep reading. Precise text like formal mathematical proofs is hard too. ChatGPT stumbles on a number of word riddles. Oh my gosh, there's actually a lot of points to discuss here. But the first and foremost is that a really good metric for thinking about large language models, of which ChatGPT is one of them, but all of these on there, is that they're really good at interpolation. And so you can imagine you have all these different data points. We've done this with univariate curves, and you want to draw a line between them. You could draw a straight line, you could draw a curved line that takes into account the slope and the higher derivatives and make it smooth. Yes, we kind of understand what interpolation means, and we all know the dangers of extrapolation. And so certain tasks in conversational AI are really easy to interpolate for reasons that we're still trying to understand as a research community. But if you take a job resume, yes, it can generate those. It's seen many of those. Shakespeare, yes, it can generate Shakespeare. A job resume in the style of Shakespeare, it can do that. And in a sense, that is interpolation. So those sort of tasks work really well for that. Mathematics, the nature of language, like specifically written language, does not lend itself well to things like mathematics. There is, oh my gosh, a huge body of work on this and trying to do this. But these generalized conversational AI at the moment are not good at doing these sorts of things. So I do want to establish this point about interpolation because it comes up in some of the other questions. And so it didn't actually, yes, it may have memorized what 12 plus 345 is, and that's somewhere in the latent weights, but it probably didn't. It has been shown that there is some basic rudimentary forms of reasoning for basic mathematics. And I say this because people have looked at the activations across the weights. It's fascinating research. It's not well understood, but doesn't really encode, I guess, higher mathematical thought. And this is why a lot of the work on formal mathematical proofs is tricky too, because it needs not just a semantic understanding, but it needs a logical understanding of how these things kind of fit together. And large language models do lack in this. Word riddles, actually, I think it used to be a really hard problem. And there's a couple data sets on puns and detecting irony. Like it's really hard for large language models, but we've seen with the latest ones, with GPT 3.5 and 4 and some of the big ones, that they're actually doing fairly well in word riddles. And I think this is like one of these problems that we're going to see solved in a sense. Humor is a thing that people like really work on, because humor requires, and word riddles and all these things, a contextual understanding beyond what's written in the text. And now that you're training it off so many billions of tokens, trillions of tokens, you're starting to see this larger like world understanding. So like, I hope that hits this first one. Ben, do you want to say anything on that?
No, you covered it all pretty well there for that question.
Great. Urban, I want to hit your question next. I'm with a local health department. How is NCHS exploring how to use this tool in its health surveys, such as NHIS and Haynes? Fantastic answer, and I will not answer it. Or fantastic question. I'm not going to answer just because right now CDC is actively looking at how to do this. So did you see how Ben showed these good examples of how to do AI wrong? We don't want to do this. We see the value in using it in surveys and using it in text. We also see the harm, especially if humans are not like closely within the loop. So, those frameworks that I had listed at the beginning, we are using those and incorporating those. We have not made any decision as an agency or as the statistical agency, so like CDC or NCHS, to do any of those. We've also not said no. So I just want to say that like we're thinking about it, and we're thinking about it deeply, and we're thinking about it hard. And one of the things that we've talked about is there something we could give as guidance to other local public health departments? Again, I'm not speaking on behalf of the agency, but we are looking at it and we are thinking about it. Thank you for that question.
Travis, can I also jump in? Because there's really another part of this is we talked a little bit about SANS before, in this identifying of non-response within open-ended survey responses. We actually, Travis and I trained that model back in late 2021, but we've been studying how the sensitivity and specificity and looking at how it performs among different demographic groups and different types of questions for such a long time. We've been studying that for a year before we could even publish it, because we want to make sure we are so aware of the potential harms of using these different models that really it's something you want to always take note of, is not just to rush in immediately like we mentioned, but really be careful and really be considerate of the different harms from that.
Thanks, Ben. Carolyn's question is next. At my agency, EPA, ChatGPT is currently blocked on all agency computers and networks. I don't know the specific reasons, but clearly the thinking is that the risks outweigh the potential benefits at this point. I'm curious whether / how other agencies are using ChatGPT. It is all over the board, Carolyn. FDA is like, this is cool, we should do it. CDC is like, let's be careful, but we're thinking about it. USDA has blocked it. VA has blocked it. EPA has blocked it. We are talking about blocking it, but we're not. What the problem is there's severalfold. There's these ethical risks that we did try to cover in this talk. There's also the IT risks, and there's also the information security risks, which I think intersect with IT a little bit. It being blocked right now is an IT decision, and it's probably stemming from that. The core problem for federal agencies is that most of the software, with very few exceptions, have to be FedRAMP approved for cloud-based services. That is a very well understood thing. And so ChatGPT, the public portal, is not FedRAMP approved. That's easy and never will be. What could be is that an endpoint and a interface could be made within, say, like Azure, and that could be FedRAMP approved. My guess is that your agency is talking about it and thinking about it. I wouldn't be surprised if they're like, we're thinking about rolling something out later or something out like this. And right now, they think it's safer to do so. Again, I can't speak on behalf of them, but I know these conversations are happening all the way across that. So I think the decisions agencies are making are governed purely by the information security. We talked about how if you put private information, it's basically lost forever. And the IT FedRAMP question is a big one. But those are different groups than talking about the ethics of using it in the first place. So I do want to touch on it because it was such a great lead into some of the other things. Okay, so next questions. And I like this one from Jason. Do you have any suggestions on how coders can use AI models beyond language conversion and debugging? So specific to programmers. I know ChatGPT can write some code, but probably not detailed programs yet. I'll turn it over to you, Ben, to start this one off.
This is okay. So this is such a great question, Jason. My line to say this, the reason that Travis passed this over to me is ChatGPT, especially GPT-4, is like having a senior developer you can ask any question you want to. I personally was enrolled in a master's of computer science because I wanted to get to a certain level of skill from programming that ChatGPT got me to. And so I left my master's program because it was that effective as a tool, which is just incredible to think about. Of course, is there certain areas, there's certain things that's going to get wrong? Sure, there's going to be mistakes, but that's a part of coding. Is a part of that process is you try code, you see where it fails, you fix that failure, and you go into the next part. And in terms of just generating code and then putting it straight into production, that's not necessarily the proper usage, and that's not the proper way that coding happens anyways. And so really saving you that time of, okay, here's an issue that I have going on. How can I solve this? If it's something that's a defined function of, okay, I know my data is going in for this structure, this set, here's the different parts of it, and you can kind of lay out how you necessarily want that function to flow. ChatGPT can generate the different outputs based off of, okay, this is what is Pythonic, or this is what it is in R. Here's that different function output. Is it fully laid out of saying, okay, I would like a website that does this? Is it going to generate every single intermediary little step? No, but if you lay it out for them of what here are the different steps that I would like it to do, depending on the complexity, it can. There is a very big difference here between GPT-4 and GPT 3.5. GPT-4 is frankly put a lot better with this. And if you have more complicated questions, GPT-4 is currently the top dog in this race. But yeah, it is also something when you talk about your prompt engineering as well as a part of this. But yeah, it is so good at being helpful with this.
Yeah, and I would concur with that. I consider myself a senior developer, but oh my God, I spend so much time on Stack Overflow all the time. It is a useful tool. Stack Overflow is a website where just people have pasted answers, like they ask questions about programming and people answer them. Importantly, it was a core data source for all of these large language models when they want to learn code. I would challenge you, like if any of you do programming at home, like do you have any side projects? Because this is, again, I can't speak for your work, but side projects at home, try to code without the internet, only ChatGPT. So if you have a question about a function, try to ask that question. If you're like, oh God, what is a bubble sort? And how do I write that again? Use those things. I find 90% of the time it's faster and better than Google and getting me to Stack Overflow. 10% of the time it's so much worse and gives me false information. And like I've learned really quickly how to use that. And it helps you develop. This is just another tool in your arsenal as a programmer. You know what else it can do that our Tiger team identified is it can take somebody's terrible code and write comments for it. Oh my gosh, it's so good. And yes, as a senior developer, you're like, yeah, I know what this function is, duh. But you know what? Nobody else does. And so writing comments in your code, right, like reducing code rot and like thinking about legacy code in your database, so good. And it does that really well because it understands the contextual reasoning of language and it considers programming code another language. So it could infer the intent. Is it going to be perfect? No, but I've used it on code blocks. I'm like, what did I write 4 years ago? Why did I do this? I'm like, oh, this kind of makes sense. So I think those are like some good starting points.
Kind of building off of that, Travis, that one part there of code commenting is just such, I really, we cannot state enough how wonderful that is, where it has, based off of Travis mentioned earlier from the reinforcement learning from human feedback, it's been trained to output in this specific way of what is to help a human be able to understand this code. And so if you're looking at learning, oh, how does this code function? Here's this code, here's this function that I found somewhere on the internet. I don't really know how it runs. Let me plug it into ChatGPT and let ChatGPT explain item by item. Oh, this is how it works. That is such a beneficial use case that I've seen coming in of, okay, I'm jumping into this new library I've never seen before. And I kind of am parsing this out. I haven't seen that. It's so beneficial for this. And especially for somebody when you're going from one language to another, just understanding, oh, what is the comparison of this to SAS? What is the comparison of this to R or to Python? It's so beneficial there. And we cannot overstate just how wonderful that is. Pass it back to you, Travis.
Thanks. Next question I want to hit is the one by Leyland Crane, who asks, have any agencies done work running the open source models on-prem? I'm going to put that out to the chat because I'm going to talk about our experiences, but I think this is like a general posed question. They continue, there are a bunch of hurdles, allowing connections to Hugging Face, getting folks comfortable with license, GPU access. Interested to hear where people are having issues. Things that we've learned is that GPUs, we know they're expensive and your IT doesn't understand why you need them. And so like there's if you want to fine tune a model, or if you want to run something of inference at scale, oh my gosh, it's a lot of talking and it's a lot of teaching. So you will be teaching them. Another thing is if you have an on-prem system that is like in an enclave or it's like completely offline, learn Docker, learn containerization, because you may be allowed to create a Docker model that has everything all wrapped up and encapsulated. We've been able to do this successfully in CDC in like 3 or 4 different locations. And it's actually really good for kind of wrapping and keeping things, off the chain and building the environment, like building up the CUDA drivers, or even if it's CPU, just getting Torch in there or TensorFlow or whatever you need, encapsulating it all in one little nice Docker image and putting it up there. And then your other collaborators in your agency can then work off these images as well. So I think that's my basic advice. Ben?
Yeah, it's really important to state is that also with all the organizations who are training these models, there's only so many who have the computing power to train them. And it is a massive investment. So that's one of the reasons why so many organizations, you've all probably heard discussions of, okay, we're moving to the cloud, we're moving to these areas, because it really does take a team to set up GPUs and that hardware and make it all set up for you. And for many of us, that's not necessarily our skill sets of going on. And so that's why Google or OpenAI trained GPT-4 on a supercomputer built for them specifically by Microsoft. Like there is so much hardware component access to it. It's just wanting to empathize is that it is hard, especially from a security perspective. There's so many different aspects of that. It's just something you're going to continually have to have conversations with, and saying that, okay, my GPU runs this large language model 7 times faster. That is a huge time save. That's why we're going through all this hurdles, why we're going through all these different pain and trying to buy these GPUs, but it's 7 times faster. And that's why we're doing this. That is such an important point to stay in any of these conversations.
And for some models, the improvement from CPU to GPU can be on order of 10 to 50 times faster, which, if you have 10,000 examples, fine, you just wait a few days. But if you have a couple million examples, you have a pipeline, you really do need a GPU. The next question by Pushpal Mukhopadhyay says, does ChatGPT assign different importance for information based off data quality sources? Will it assign a higher weight to information coming from CDC versus weights coming to information from other sources, such as myjunkhealthdata.com? Is that a real website? I don't know. Somebody can let me know if that's a real thing. But I understand the intent of the question, and my answer is I cannot say definitively. One thing that's really frustrating about ChatGPT versus other public models that are out there, especially the open source ones, is that they didn't tell us actually what the training data is. And I think they did so that they could protect themselves from lawsuits, because I'm fairly certain, and we had examples that we didn't put in here, that there's plenty of copyrighted material that's built into it. So we don't know where data's come in. People have done some really cool things to be like, there's information that only exists on CDC's website. It's really not anywhere else on the internet. Can you reproduce it? Yes. And so like you can infer where some of the content is coming from, where these tokens are from. That is like, I think it's a New York Times article. I could pull that one out if you're interested in. But talking about where the weights come in, again, this is speculative. I don't think that there is a priority to this. And I know this because when we wrote the pile and we trained these large language models, like the pile was used to train GPT-Neo and GPT-J. You don't put weights on them. It's too hard and too big of a task. What you do is you decide to exclude things from the data set originally. And kind of an illustrative example, when we were making the pile, we were like, what is all this publicly available text that we could use for large language models? PubMed is a really good example. USPTO, right? All the patents. These are all really good things we want in there. Stack Overflow, cool. We can pull this public information. We're allowed to do so. We have the licenses. this is going to be a resource for everybody else. You know what else was in there that we decided not to put in was all of court law. So like if you look at court law that comes in, there's lots of really good stuff, and we added some of that. We didn't add stuff from the 1800s, even though there's lots of great text from there, because we didn't want to include the way people were depicted back then. You may remember the 1800s has a different viewpoint of how, say, African Americans are viewed as human beings. And so we made that filter ahead of time before we added it to the data set. It's not really that easy to kind of post haste add weights to these things. But again, speculative, I can't speak on it because they didn't write it up.
Yeah, and I also want to jump in because that is such a good question. There has been some movement, for example, Llama by Meta, they have specifically said, okay, here's where data comes from. It's 25% from Stack Overflow, it's 15% from Wikipedia and that type of thing. But again, at this scale, it's just so hard. It's such a hard task. And especially with how OpenAI considers GPT-4, their internal value of how much it's worth to them, that's where they view their value at is from these weights from these different models. And so they don't want to give any information away about, okay, GPT-4 is so good, how could Google figure out a way to make a better model? And so a lot of this they view as their own internal information to keep their models being better than everyone else for this. And so there's a lot of conversations with that, but that is an important thing to also state.
Yeah. I heard an analogy that somebody was likening it to a recipe. They'll serve you all the cookies, but they're not going to give you the recipe on how it was baked. And you know, there's like baking powder in this, you know, there's eggs in it, but like what made it so good? Or like, why does it taste weird? Like they're not telling you that kind of crucial ingredient, the instructions, the recipe for it. Going back to Stas notes that ChatGPT does not produce reproducible responses. Let me just stop right there because let's hit that point and then get the rest of the question on purpose. And that's how large language models work. They're not a data query system. They are not a computational engine. What they do is when you say the cat in the blank, they produce a probability distribution of all of the next words that could possibly be, from the cat in the hat to the cat in the chair to the cat in the, which doesn't even make any like syntax sense. And it looks at all these probabilities and it decides to pick one based off this probability distribution. It's a little bit more complicated with that, with logits and all this things and temperature. Let's ignore that. That's a different conversation. But if you run it again, it will stochastically pick a different one by construction. That's what gives it the utility. That's how it's trained, because all language models have to effectively be smooth so that the weights can be iteratively adjusted. So these logits are kind of like adjusted up and down, whether it gets it right or wrong. So by construction, it doesn't produce reproducible responses. And that's not a bug. That is effectively a feature and a fundamental aspect of how these things work. So if you give it the same prompt, it will, not likely, it will produce different responses. There is a trick, since this is a training thing, you can always make it return the most probable response, and then it will be deterministic. This is this thing called temperature. If you set the temperature to 0, you will always get the same response. It will be kind of boring and it won't change. It's good for testing purposes. So if you want to build a little API and you want unit tests, make temperature 0, which you can do through the API. Okay, this is hard to stomach for government statistics where the answers have to be stable and precise. Census API is stable, while Open API is not quite. I don't think you should compare them because they're not solving the same task. Census's API is designed to effectively query some data, and that should be reproducible. ChatGPT is designed to help with certain tasks, and these tasks require it to not be stable, to give different inputs as things go. Thinking about ChatGPT as an API is a fascinating one. I don't like this idea of using these large language models kind of as chatbots to interact directly with humans. I think it's problematic, and I think the NIST AI RMF really gets into this, like, putting a human in the loop actually makes these things really powerful. As a programming tool, as a PD writer, as a thing to help you process large amounts of information. Somebody talked about public comments, which we won't have time to get to. Using it for those tasks and then having human review, so good. You could use an API to hit it 10,000 times and then summarize all these responses together. Yes, that's what you want. But you should not expect it to be stable because that's not its intent. Ben?
Yeah, and another important point to talk about is that OpenAI they are trying to make money off of this. And so they're updating their API very regularly with this. For example, this past week, I think 2 days ago, they updated it because the output of it was supposed to be specifically one of the examples of that they added was people oftentimes would ask output from GPT 3.5 or GPT 4 in a JSON format, a type of specific data conversion format, and they added that in because people were asking for it. And that's how OpenAI wants to make their money, is they want to cater to people who want to pay them money versus for census, that's a very different form. And so just keeping that organizational, what is the business need from the different groups there. But Travis, pass back to you.
Thanks. Alexander, you say, what do you see as the most promising project applications for generative large language models at CDC or NCHS? I don't want to get into the specifics for these reasons that I kind of outlined, but I do want to point out, like, I think a lot of people use AI and ML right now that are data scientists. You know, it's like somebody will come to Ben and be like, cool, I got 10,000 public comments, help me make sense of them, do some unstructured learning, unsupervised learning, put them into clusters, tell me what to make sense of this data, or I want you to train a model that can detect when people are mentioning opioids, even if they spelled them wrong. Cool, named entity recognition. These are like these data science tasks. And you say, as opposed to personal productivity uses, I think this is under-recognized by data scientists, how transformative it is for somebody who is not a data scientist or doesn't have these skills to be able to kind of access these things already. And so, like, I don't want to dismiss the personal productivity issues. Those may be some of the killer features that are truly, truly transformation. In terms of project applications that don't use that, you know, given that disclaimer, I think processing things like public comments or processing things where you don't need to know the exact answer, but you need a decent answer quickly. You need to know what is the magnitude of something trending. So this is a really good example of that is like, this is not what we're doing, but I have colleagues in the State Department that are thinking about this sort of thing. Like, what's trending on social media, for example, is a common question that comes up a lot. You know, given a hashtag, what is the consensus for something like this? This is something where these like conversational AIs are actually really good at, because the nature of it changes so much, and it's really hard to write something so fixed and structured as a machine learning model. So like, I think we're seeing the capability beyond the personal productivity uses of kind of templating and just getting something working and running. And sometimes that is the correct context for use. Ben?
Yeah, I do a couple other points, not necessarily from a CDC, NCHS perspective, but from a general field perspective. First, if any person uses Google at this point, you're using a generative language model. They've added in large language models to the search function. And so adding in that information of, okay, what does this word actually mean based on the context of so many others? You're already using it at some scale. And if you use Office or if you use all these other different products, it's going to be added in. It's just a question of, are you directly or indirectly using them? Another one is there's been a lot of work done within the data science community and this open source community of looking at PDFs and getting information from these different documents, whether that's documentation or these different areas of just, okay, how do I access this, or how do I access this code base, or how do I, all this information that it might take you 5 or 10 minutes to look at, to go through. There's so many different areas there. This is something that so many people are really looking at to how best leverage use. It's just so fascinating moving forward that I'd love to see how people use them moving forward too.
All right, I think I see Nathan back, so that's our cue to be pulled off stage. Nathan?
Yeah, we have just a couple minutes. I really thank everyone for their really thoughtful questions. And of course, thank you to Travis and Ben for their presentation and comments today. I'd offer you a chance to offer any concluding remarks and point users in the chat that when we shut this down, we'll open a new Zoom instance for the afternoon content. There's still time to register if you want, but Ben, Travis, any concluding remarks for us?
Yeah, I'll just close. Like, again, remember how fast everything is moving. So be ready to adjust your expectations. And for you in a federal agency, please do not use this for official output until you've been cleared to do so. This is your this is the warning and the disclaimer that everybody's looking at it, and we want to get it right as the federal government. This is a personal note. I don't want to mess this up. I think it's a great tool, and there's so many ways to do it wrong. And so I hope this talk helped you kind of figure out some of the pitfalls, but also some of the excitement. And so move forward, be careful, be ethical as you approach generative and conversational AI. Thanks, everybody.
Thanks, everyone.